Hi, everyone. I hope that all the members of the UN got those SDG questions right. My name is LIRNeasia from Pulse Live Jakarta.
And I'm Tavisha from LIRNEasia.
So for this session, usually the way it goes is people stand up and explain what is the definition of big data, how can it be used, the opportunities and challenges. Today, Tavisha and I thought we'd switch the order a bit. And so we'd like to talk first about some of the use cases. And since there's a lot of debate and a lot of hype about big data, we really wanted to go through the use cases and then have a discussion with all of you on what you think the definition of big data is. And after that, we can look at challenges and opportunities.
Thanks, DS. So what I'll be doing right now is I'll go through 4 use cases, 2 that LIRNEasia has undertaken and 2 from other researchers. And I'm going to focus on one particular data source, which is mobile phone data. So as we all know, mobile phone data is becoming increasingly prevalent, even in developing countries. And there's opportunity to leverage citizen-generated data from citizens' mobile phones for development applications, like improving urban planning, disease propagation, finding out the mobility of people after disasters, things like that. Okay. Cool. So the first example I'm going to look at is inferring mobility patterns of populations. So for example, if you look at the image on your left, these are results that have been derived from the analysis of mobile network data. So what you can see here is the areas in blue refer to the population. This covers the population density of Colombo, which is Sri Lanka's commercial capital, and its surrounding regions. So what we did here was we tried to look at the change in relative density of the populations at 1 p.m. on a weekday relative to midnight. So the areas in red or yellow show the areas that have shown an increase in population density, whereas areas in blue show the areas that have seen a drop in their population density. So as you can see, that during the day, Colombo, the capital, has seen an influx of population from the surrounding areas. Now, if you look at the image on the right, that shows the transit points, the transportation transit points that were found using a costly transportation survey of 40,000 households. So you can see that there's quite a bit of similarity there, especially in identifying the pockets, the hotspots of population density increase. So if you go to the second example, this is on disease propagation. Now, this project we did in collaboration with the University of Moratuwa. I think our colleagues are there, somewhere there, and the Ministry of Health. So what we did here was we looked at multiple data sources, including mobility data derived from mobile network big data, as well as historic dengue cases from the Ministry of Health, temperature data, rainfall data, as well as satellite-derived variables, such as the normalized differentiation vegetation index. So what we did was we integrated all these data sources to develop a predictive model where we could identify the areas that were at high risk of dengue cases because of mobility. Now, we know that policymakers like to know where they can target their resources, especially in resource-constrained environments. This is an example from Rwanda. This is what Joshua Blumenstock and his team did, where they tried to use an individual's digital footprint, that is an individual's mobile phone usage, to infer his economic status. So they combined mobile phone data with survey data to estimate an individual's socioeconomic status. And what you could do from this is that you could then build up and predict attributes for an entire nation, or you could also go down and look at socioeconomic estimates at a much more granular level. So you can look at it in terms of microregions. That can be a couple of hundred households or few households. So this is the potential that you have in using mobile phone data. Now, the final example I want to talk about is the movement of population after disaster. Now, we all know that we need to know where the population goes, the displaced population goes, in order to provide targeted relief. So this is what the team from FlowMinder did. What they did was they looked at, this is an example from the Haiti earthquake in 2010. And what happened here is that they looked at the movement of population before and after the earthquake. And you can see the area in red is the center of the earthquake. That was Port-au-Prince. And the areas in blue, the circles in blue, denote where the displaced population has moved. So this shows the movement of population 19 days afterwards. This is where the population was. So this is the population that has moved out from Port-au-Prince to other regions. Now this, again, this aligned well with a retrospective UN study that they did to understand displacement of population. Dias, do you want to cover a couple more?
Thank you, Thavisha. So where I come from in Indonesia, despite the penetration rate of cell phones being around 120 to 130%, it's very hard for us to access cell phone data, and that's another issue that we'll be talking about later. But we've experimented a lot with social media data, and especially with Twitter data. One of the things that we've done is look at whether we could use the data from Twitter to nowcast food prices. We found that this worked when it's a commodity that people care enough. For instance, in Indonesia, beef and chili, those are the things that people care about. And when prices go up sufficiently highly, people get enraged and then they complain about it. So we found that this model works to see what is the current price now of commodities like this that have emotive value. What we also found that the sensitivity of this model improves when prices go above a certain psychological threshold, but when prices go down, people don't have anything to complain, and therefore it is less sensitive. Another example of using social media data is for commuting statistics. So in Jakarta, our daytime population is somewhere around 10 million, I think. And if you think back to your behavior when stuck in a traffic jam and you've got your smartphone, what do? You either open stuff up or tweet, and when you're angry enough and you're sitting in public transport, you complain about traffic. Or you Google other things and then tweet out interesting articles. So there are millions of tweets produced by Jakartans who are stuck in traffic each day, and we wanted to see, can this be used? Can the location data from those tweets be used to mimic the results of a survey? So we took the 2014 official commuting survey from Indonesia's National Statistics Office, and then we took Twitter data from roughly about the same months, and then we analyzed location and origin-destination pairs. And as you can see here, the results are quite close. When calibrated, it has a correlation of 92% with the official statistics. Another example is to track climate anomalies. And here's the data that we used is in combination with other sources. We used rainfall data to map out rainfall anomalies to see whether an area was potential to drought or not. And then we overlaid this with census data to look at people living in poverty and the World Food Programme's food insecurity data to see where people are at risk of food insecurity. And so when overlaid with these three data sets, you can see the combination of people affected by inclement weather, by droughts in this case. You can see the areas that people are affected by droughts and are poor, and you can see where people are affected by droughts, poor, and food insecure. Yours, Tavisha? Oh, sorry. So based on this, I think Tavisha and I would like to have a conversation with you. What do you think is big data? What are some of your definitions that you can put forward? What do you think it is? We've got 6 roving mics. Tavisha and I have each got 1. So in all, we have 8 mics. And I'd love to hear from you. No need to go to Pigeonhole. This is a straightforward, traditional, grab the mic and state your opinion kind of thing. Oh, come on. Anybody? Yes, please.
Can you talk a little bit about the ethics of using big data? And because, you know, people are not aware that data is being used for these kinds of things. I understand the value of real-time data, but so I have 2 questions. One is about the ethics, and one, how is it possible to look at something like leave no one behind when the data point itself may be how would you assign?
We will discuss that, but I'd really like to get your opinion first. What do you think big data is?
To me, well, from what I know of it, it is a kind of telephone data that is on that's on your mobiles, for example. That is not something that is there because it's there for a data purpose. Data is just generated because it's electronic and it's used for something else.
That's excellent. It's not purposefully generated. It's a byproduct. Thank you. And I will take your questions on board on ethics. Another one. Another opinion? Yes, please. Gentleman in the back. Oh, yes. Yep.
Yeah, I think big data is really large data sets, as you said, which have been derived for various other purposes, which are put against other data sets to really show how people are interacting, what they're doing, and the reasons why they're doing what they do, or think how they think.
Fantastic. One more?
Yeah, so I think big data changes the way we ask questions. We used to design a survey and try to find out particular data that we wanted. But with big data, all you have to do is the data is already there in a mass form.
Yep. And
you need to know what kind of question or query you want to bring to this data so you can mine whatever information you want.
That's a great aspect, the analysis of it. From this side of the room, I haven't heard anything yet. Any opinions on what exactly is big data? No? All right. Tavisha, maybe you'd like to go through the next section on how people commonly conceptualize big data.
Sure. So the origins of big data is shared between academic circles, industry, and the media. But the term itself is amorphous, and there is actually no single definition. So what we're going to do is we're going to look at a couple of characteristics of big data. And I think, as somebody rightly said, at the most basic level of understanding, big data is dealing with large and complex data sets. But in addition to that, it also looks at data that's at the speed in which data is generated, assessed, and stored. And finally, it's also about variety, because it can come in multiple formats. It can be text, audio, video. Data can be structured, unstructured. So these are some of the characteristics. There are others as well, but we thought we focus just on these 3. But maybe, Diaz, you can elaborate with a couple of examples.
Yes, I think Mark from WHO mentioned this morning that there is an abundance of data. And quite rightly, he was pointed out that these are not purposefully generated. They are exhaust. They are the digital trails or footprints of our daily interaction with platforms. But if you can see, sometimes there is an information gap where often to find out things on hunger and poverty or on education, the way we traditionally generate data takes 1 to 3 years to be able to have something robust to interrogate. In contrast, if you can see there, that is the amount of data that is produced in 1 single minute of every day. And this includes the amount of tweets, the amount of clicks on the Weather Channel, Giphy, Netflix, Snapchat. All of these platforms contribute to the abundance of data. Some other data sources that are around you that you might not realize might be useful would be from commercial transactions. Every time you go on online banking, or every time you have online purchases, or even use your credit card, that leaves a digital trail. Sensors and traffic tracking devices, including road and traffic sensors, your GPS, your mobile positioning system, climate sensors and equipment, those generate data as well. Administrative data, your medical records when you get into hospital, your insurance records, your tax records if they're submitted online. Also, as I mentioned previously, your activities on social media, every single tweet that you have generated, like the immense Twitter wall that we saw, every time you tweet, you give away about 50 points of different kinds of information about yourself.
So what's the role of big data in sustainable development and in the 2030 agenda? So let me cover a couple of insights that can be derived. So I think Diaz covered a couple of sources of big data, several types of sources. But in the interest of time, I'm going to focus on one source, which is mobile network big data. And I'll just run you through some of the variables that can be generated, the insights, and the applications. So first thing is, when a mobile phone is used, a call detail record, which is known as CDR, is automatically generated by the mobile network operator. So that happens each time we make a call. So this contains information such as the recipient, the time of the call, the duration of the call, things like that. Now, if you get a monthly phone bill, if you look at the itemized list, that's essentially your call detail records. Now, in addition to this, mobile operators also know the cell tower to which your phone is connected each time you make a call. And because they know where their cell towers are, they can figure out an approximate location for you. Now, there are 3 types of behavioral variables that can be generated using this data. One is mobility. So if you're on the move and you make a call, for example, you will be connected to multiple cell towers. And using that, you can infer your direction and movement pattern. Similarly, connectivity variables. What this means is that we use our cell phones for business purposes, for personal purposes, and you can look at the frequency and duration of calls to kind of get an idea of your social network. And also consumption variables. Mobile phone operators have information on when you make a payment, how much your phone expenditure is, how consistent you are. And that can be used to kind of get an estimate of your income. So the insights that you can derive from this are human mobility patterns, social networks, and economic activity. So if I focus on the first one, which is the human mobility patterns, as I told you, because you're connecting to multiple cell towers, you can infer certain patterns. And that you can do it at an individual level or at an aggregate level. So you can get insights on an entire population, the movement of a population. So while that itself shows the mobility patterns, it has applications, as I mentioned earlier, for disaster, to understand where displaced population go. You can understand, it can be used for urban planning, to understand what are the pockets of congestion, where does this come, as well as socioeconomic status. Yeah.
So summing up Tavisha's explanation, this kind of data, highly unstructured, complex data in abundance, can give us insights into what people say and what people do. But I'd like to ask you again and sort of rouse you up, what do you see would be some of the value of this type of data for sustainable development. This morning we spent a lot of time talking about the Sustainable Development Goals and integration of data sets, and I see in the room several high-level experts on statistics and on data, but what would be the value of integrating something like this? I'm focusing on this side of the room because I haven't heard from this side of the room. Okay, maybe that side of the room. What are some of the values that you see? Do you think this is a hype that people are like, yeah, okay, fine. Some people use it, but it's of no use to me. But can you see a direct value? No? So,
hello. Yeah, yeah. One possible application is to track over time the change in socio-economic status to see if everyone is basically getting more rich at the same rate, or if there are pockets that are left behind.
Yep. Any others?
More effective allocation of resources and speedier contact with people who really need the change and need resources for change.
Any others? Yes, please.
Just want to know, because big data is you get large number of data, is there a validity in terms of quality, in terms of quantity?
Quantity.
Yes, quantity is high, but the quality.
That depends on which type of data set, I think.
Yes, so the validity, because you get the analysis. To validate, do you need on-site other mechanism to validate? So that is my question.
Yes, definitely, and that is something that we will discuss later on, how to triangulate this. But, okay. Just to recap on some of the value, we can have new insights, mined in different ways. Some of the cost of data collection, surveys are expensive to conduct. This can be lowered down. In places like disaster areas or conflict areas, you can reduce the risk of data collection. You can also have a speedy response if it's real time. So for instance, your traffic management policies or your urban planning policies can be tweaked, which leads to the last question on adaptive execution, where you can actually adjust your policies if it's not working well. So we have two questions on notice. One is on ethics, and the second one is on validity of the insights.
So I think that's a good lead up to our next section, which is examining some of the challenges. So I think you brought up a couple of questions as well, which we can get through at the end. So one of the challenges that we face is data from government. So by this, what we mean is that not all the data is digitized. And if the argument is that we pay more attention to data, then we need to take care in digitizing more things. So for example, I think the open data movement is spearheading some of this as well, but this remains one of the challenges.
The second one relates to both these questions. On accessing data from the private sector, there are a lot of ethical questions on how we do that. For instance, our mobile call records. Yes, the locational data that is in there is highly useful and will be highly useful for things like urban planning and disease monitoring. Social media data, useful for things, tracking mobility if they're in high density, and to look at things like public sentiment and people's feelings on a certain issue. But these contain our personally identifiable information. And the challenge would be, as governments, of course, how to use that judiciously for social good. Also, another thing about accessing the private sector data is that, unlike open data, this is it's a commercial product. There is value in that. And often the private sector is not amenable to their data being accessed. Often the ability to access the data then compromises their competitive commercial advantage.
And I think one of the biggest concerns is around the issue of privacy. And higher the resolution of the insights we generate, the greater the privacy implications, right? And I think that's a very fair concern that we have. Now, one of the major concerns of this is secondary use. I think that was the point that was raised earlier, which is data that is being collected for one purpose is being used for some other purpose. So, for example, even in relation to mobile phone data, you're using it for something else that was not the reason that it was collected for. So how do you get about this? One way that has been proposed is informed consent, where you get the consent of the population. But then that raises the question of how often do we do it? Do you get a blanket consent form? It can go into hundreds and hundreds of pages because you need to list out every possible application of this. Or if you don't sign it, then you don't get the service. So this is one of the key concerns. The other concern is on disclosure, whether this will reveal true information about a person. Now, one way, again, to sort this is through anonymization. This is where you strip a data set of every personally identifiable information. That includes the number of the person, their gender, anything that can track that particular data point back to an individual. Now, even in this case, one of the concerns is the issue of aggregation. So you have a non-personal data set, but if that is merged with other data sets, then there is again potential that can lead to re-identification.
Another thing that also links to ethics and to your question, madam, about validity is whose voices are we counting here? If big data relates mostly to digital footprints, does that mean if you don't have a digital footprint, then you don't have a voice, then you are not counted? Who is actually being left out here? When we do big data mapping and we take, for instance, the Twitter population of Jakarta, we can take the entire Twitter population of Jakarta, but the entire Twitter population of Jakarta is not the same as the population of Jakarta. And this is where I think it's quite important to remember that big data does not replace a lot of things that conventional statistics do. We really need to triangulate that with surveys that have been done, with things that are not leaving digital footprints, but are important. For instance, mobile data on expenditure. To know that these kinds of patterns represent a certain household, we must know in depth about that household. This is where a traditional social survey would actually make a lot of sense. And these need to be used in triangulation to make sure that while we're getting excited about the potential of these new data sets, we don't be exclusive and then we forget about people who don't have the digital footprints, who are not counted here.
Another challenge that arises with the use of big data is a need for new skills. So for example, our study on disease propagation, we had to reach out. We worked with the University of Moratuwa for technical skills. We had to work with the Ministry of Health for subject matter expertise. So it requires a combination of specialized skills. For example, national statistics institutions have in-depth knowledge of statistics. What this would also require is advanced machine learning skills, skills in relation to computer science, decision making, decision science, things like that. So there is a need. It's difficult for one organization to provide the entire gamut of skills.
Before we move ahead, though, we really wanted to open up the floor for questions. So far, are there any questions that you'd like to ask of us before we move to identifying opportunities together? Any questions? Yes, ma'am.
Thank you for the great presentation. I actually come from an anthropology background, and one of the concerns that our discipline has had about big data is that it really doesn't show the cultural nuances and what are the nitty-gritties about it? What are people really thinking? Why do they really do what they do, etc. Because this is really surface-level data and don't really go into the depths of people's cultural patterns, their beliefs, and their lifestyle. So how do we kind of have a bridge between these two aspects of data and qualitative approaches?
So what we do at Pulse Lab Jakarta is exactly try to combine that. We try to combine big data and thick data, the in-depth data that shows not only what people say, what people do, but also why people do these things. We find that in terms of identifying research questions, it's a bit of a messy process. Often it starts from the data analytics. For instance, we had a project on mapping out haze. We looked at haze signals from satellite data, which correlated very strongly with tweets from a certain area. But then when we put it out on a map and we identified trends, there were several questions that came out from the data. One was that the hotspots were in one area and the Twitter sort of signals were concentrated mostly on urban areas. We then worked with a team of ethnographers to find out why that was. And we found out that in the areas that are directly impacted by haze hotspots, people often did not have access to cell phones or social media or internet. And also some of the lumpiness of the patterns of tweets were explained by the lack of actual information getting through to people who tweet, and also, interestingly, that people organize tweet mobs in order to raise a certain hashtag so it gets the attention of, say, national authorities. Those kinds of insights wouldn't have happened had we not worked with ethnographers. At the same time, to narrow down what to examine deeply, that is a big function of advanced data analytics, I think.
Yeah, how do you handle the cases where people switch between networks, mobile networks, because they'll be using, the same person will be using a different SIM each time, so the data you'll get from each network will be an incomplete picture of that person's usage, plus there's no way to correlate, to tie in a particular user to a particular network, I guess.
Ganesh, would you like to address that?
Let me sort of just answer that question and sort of give a broader comment about this. Based off the comment that the lady earlier mentioned, you know, I mean, we're all running around this term big data. It's a big hype, and I work with big data. The real value is really about mixing all of these data for a particular purpose. And in that context, it doesn't matter where the data comes from as long as you make best use of it. So some of those why questions cannot come from big data. It has to come from ethnographic studies, focus group discussions. Big data can give you the what, for the why you go elsewhere. And really the whole thing is about how do you mix these methods together? That's the end goal. The question of, I think that's a very important question. You need to also then think of big data as this sort of onion that you have to peel the layers around one by one. You not worry about switching behavior, etc., to understand general trends of how people may be moving about, making a lot of assumptions along the way, right? But as you start to get more into decisions of, are the bus routes from point A to point B, you know, what they should be? Are we having enough people that the transportation is meeting the needs of the people that have to go from point A to point B? Do we capture the people exactly at point A to point B without overrepresentation or underrepresentation, right? To do that, then you need to start adding additional methods, like doing surveys, doing calibration with the big data, which is an anonymous mass of data of people we don't know anything about, versus understanding some demographic characteristics. Is this 50% men, 50% women? what age groups, those kind of demographic characteristics that you may need for, let's say, I'm using the same example of transportation, right? So you take one particular data source, and then you start to use other techniques, other methods, other data to flesh out some of these questions. So for example, the switching behavior, you could get to that answer if you have data from all the operators, right? But if you have from one large or two large operators, you get a subset of the population. So this question that Diaz raised, representativity, representativity, representativity. Three main considerations for the use of big data. Who is this that we're talking about?
Any other questions?
Thank you. Maybe I may be wrong, but I need a clarification on this. As he said, if the big data is an onion, it takes more time to make decision, I suppose. So instead of having structured data collection, which directly focus on an intended purpose, when we have big data, it will eventually delay the decision-making process, I suppose. So how would you suggest in terms of decision-making and its relations to big data instead of going straight forward data and making decision?
So actually, on the other hand, big data, it's sort of the opposite. Because using big data, you can derive near real-time insights. Because the data is generated in real time. And with advances in technology, you can analyze this data, you can store this data. So you can generate insights in near real time. So if there is a disaster, you can immediately use the information you have available, run some analysis, and figure out where the population has gone. So what it can actually do is speed up decision making.
I understand some of your concerns, though, because I think some of the length of time it takes to have something as a valid proxy of something else, like you pointed out, the validity part, that does take time. For instance, can Twitter data be used for commuting proxy, or can they be used to map out certain price trends? That takes a statistical process, and you need to be sure that these are correct proxies. But once you've established that there is a high statistical correlation between data source X and data source Y, and data source Y being something that is ground truth, that you check and that is there in reality, then things move fast and you can use it for real-time data. But I understand your concern that that beginning part, that does take some time.
And I think just to add to that, just to use an example from UN Global Pulse, traditional statistics, they compare it to a high-resolution photograph. So you can, it's very clear, you can see everything, but it's static. Insights generated from big data, on the other hand, can be compared to a low-resolution video. So you can see movement, but it's low resolution. And what it can do is provide a sense of directionality. It's more of a diagnostic element.
Any other questions? Any other questions?
Yeah.
So, oh yes. Thank you for breaking that awkward silence.
No problem. What I wanted to ask was, we've focused a lot on mobile usage as big data, but big data is not just generated through mobile methods. So maybe we can also discuss some of the other forms of generation of big data. For example, if you take SDGs like life on land or life on water, you have so many other methods, such as a mosquito species going through a laser, or you have the radio collaring on migratory birds that also generate very large data sets that can then also inform things like conservation efforts. So maybe we can also discuss about the broader sort of sources of big data as opposed to just mobile usage data.
Yep. Certainly. Some of our work has looked at things like combining different data sets. For instance, using e-commerce data to see actually things like affordable housing. So in one of the e-commerce platforms that we had access to data to in Indonesia, there was a place where there was a feature for people buying or selling and renting houses. So in one of our data dives, we had a look at that, and then we were able to map out, okay, for this particular area, what is the rate? Is it actually better to buy or better to rent? So that's more of an economic decision, but what this body of data can also tell you is the cost of housing in various places in Indonesia where the data is available. Another thing is ship movement data. And if we look at, so for this we need actually to triangulate different data sets. We haven't implemented this, but we're dreaming of this project. If we can look at where fisheries catchments are, where protected areas are, and we have vessel movement of shipping vessels, then we can see where vessels are fishing, where the fish is being landed, and then map these out against catchments, whether they're protected areas or not, whether it's overfished or not. And so we have sort of a real-time gauge of what's going on in terms of sea resources. But as Tavisha mentioned, this is a blunt instrument to see what's happening, where is it moving, in order for us to assess the natural resources that are still available, the types of fish that are still available. That's not coming from this particular data set. Tavisha, do you want to add from your project?
Sure. So I think something else that another source of big data is satellite imagery, satellite data, sensor data, things like that. We have been exploring the use of satellite imagery in land use estimation, so to figure out if it's a residential area, commercial area, mixed use. We're also thinking of using satellite imagery, combining it with ground data for crop yield estimation. So there is a whole range of applications of various types of big data for the Sustainable Development Goals.
Actually, that reminded me. One of the projects that our sister lab in Kampala in Uganda have done is used high-res satellite imagery to look at roofs. So they found that the attachment, what the roof is made of, is a good indicator for the level of wealth of that particular household. And they ran a large amount of satellite imagery to then map out basically household wealth across different regions. And going back to what that gentleman said, if you have satellite imagery over time, then you can see longitudinally how wealth increases by what kind of roof topping that they have, and mapping that out over time would give you an indication of how well that place has developed.
Yeah, I think just to wrap this session up, maybe we can just touch on a few major opportunities that are probably there.
I think we mentioned some, but are there any other ideas apart from what has been mentioned before that you can think of?
Cool. So just to kind of emphasize, big data is not a replacement of official statistics. It's meant to complement official data, maybe in the interval between traditional surveys to kind of give a directionality. So that is where the opportunity of big data lies, in complementing traditional statistics. And I think there was also a question about, the SDGs focusing on leaving no one behind, and what about the people left out. So let me just quickly give an example of one particular app called Street Bump, used by the city of Boston, where they use this app to figure out potholes in the city. Now, if we are going to use that, There will be concerns about the fact that, smartphone penetration is not as high as the city of Boston. And it would be that people with a lower socioeconomic status may not have access to smartphones. So does this mean that this app has no relevance to a country like Sri Lanka? What this app could provide is potholes on certain roads. So you can get data for certain roads. But if smartphone users don't travel on particular roads, we have access to the entire road network system of Sri Lanka. We know which roads are now not being measured. And that is where we can focus our resources. So this can give you kind of it can be a diagnostic tool to figure out, okay, what are the areas that are not being measured? And then you can focus your resources on that. So that's an opportunity there.
Yes, and I think Tavisha and I would like to just end with this slide. There is a wealth of expertise amongst you, so I hope you will use this 2 days with this lens in mind. Moving forward, what can we do together? Thank you very much for listening to both of us, and I wish you all the best for sessions to come. Thank you.